So far with quadrilaterals, four-sided figures, we've already taken a look at parallelograms, and we've seen all of these different things that are true about parallelograms. Now we're going to move on to rhombuses. Rhombuses are going to have one feature that's very, very distinct from parallelograms. Whereas parallelograms had two sides, or two pairs of opposite sides are congruent, rhombuses, all four sides are going to be congruent. So we can go ahead and put markings in on all four of these sides to show that they're congruent lengths. Now, just like parallelograms, we know that this side is going to be parallel to this side, and this side is going to be parallel to this side. The next thing that we know is that, just again like parallelograms, the opposite angles are going to be congruent. But before I draw those congruency markings in, I want to show you what's true about the diagonals. So the diagonals, as we draw them in, what's going to happen is that each of these angles that the diagonals hits, the diagonal is going to bisect that angle. So what that tells us is that this angle here is congruent to that angle there, but it's also congruent to the angles down here. So these four angles are all congruent to each other. So if this angle was, say, 25 degrees, then that means that 25, 25, and 25 degrees are also there. Now, going over to the other pair of angles, that means that these bisected angles are also congruent. So we can put our markings in there. Now, the diagonals, they are going to bisect each other just like they did with parallelograms. So we know that this here is congruent to this here, and this here is congruent to this here. There is one more thing that we do need to know about the diagonals, and that's the diagonals are going to be perpendicular bisectors of each other. So that means that not only are they going to bisect each other, they're going to do so at 90-degree angles. So we can go ahead and put a right angle box in right there, and then we know by vertical angles and by linear pairs, all four of those angles are going to be 90-degree angles. So those are all of the things that you're going to need to know about rhombuses. So opposite side, or all four sides are congruent. Opposite pairs of angles are congruent. The diagonals are perpendicular bisectors, and the diagonals are also angle bisectors. And so that's everything you need to know about rhombuses. Rhombuses we're going to put over here underneath parallelograms. So the last thing we looked at was rhombuses. So rhombuses are going to be parallelograms, and parallelograms are going to be quadrilaterals. Now rectangles are the next thing that we're going to look at. Rectangles are parallelograms, but they are not rhombuses. And the reason why rectangles are not rhombuses is because they have different lengths on their sides. So here are the rules that you need to know for rectangles. Just as you have with parallelograms, you're going to have the opposite pairs of sides are going to be congruent. So two pairs opposite sides congruent. Then all of your angles are going to be congruent as well. So that means that they all have to be 90 degrees. Just as with parallelograms, all of your opposite sides are parallel. So we'll go ahead and put those parallel markings in there as well. And then when we get to the diagonals are going to bisect as well. So we get this is congruent to this, and this is congruent to, actually all three of them are going to be congruent, or all four of them are going to be congruent. So when you're doing the diagonals of a rectangle, all of your diagonals are going to be congruent to each other. That means that they're also going to create four separate isosceles triangles within the rectangle. So here you have one. Going over to the opposite side, you have another one that is going to be congruent to it. You have, on the top, you have an isosceles triangle, and right below it, you have another one that's going to be congruent to it. These angles are congruent by vertical angles, but they are not going to be 90 degrees like they were with rhombuses. The next shape that we're going to define is going to be the square. Now, just as we said that all parallelograms are quadrilaterals, all rhombuses are parallelograms, and all rectangles are parallelograms, What's interesting about the square is that every square is going to be both a rectangle and a rhombus. And so since it's both a rectangle and a rhombus, it's also going to be a parallelogram and by extension a quadrilateral. So what that means is that squares are going to share some of the characteristics of both rectangles and rhombuses, but they share only those characteristics which would make it both a rectangle and a rhombus. So let's take a look at what defines a square. Just like we had with a rhombus, all of the sides are going to be congruent. So we can put congruency markings for every single one of these sides. All of the sides, or we have two pairs of opposite sides that are going to be congruent. So we have there, and then we also have along the sides there. Now, just like with a rectangle, our angles, our interior angles are all going to be 90 degrees. And then what we're going to do is we're then going to take a look at, again, how are they more like rhombuses? If we draw our diagonals in, then what's going to happen is these diagonals, they're going to be angle bisectors. So that means that this angle is congruent to this angle, but since all of our angles were 90 degrees to begin with, then that means that all of our bisected angles are going to be 45 degrees. And we're going to have 8 of those. So you can see that we can go all the way around this square, and we get all of those bisected angles are going to be the same. Then, just like with rectangles, all of these diagonals are being bisected, and they're all going to be congruent to each other. So we can go ahead and put congruency markings in there. But then again, just like a rhombus, when those diagonals bisect each other, they're going to bisect each other at a 90-degree angle. So those diagonals are perpendicular bisectors as well. So you can see these are all of the traits that show you that the square is kind of a mashup between a rhombus and a rectangle. But in the end, they're all parallelograms and they're all quadrilaterals. In problem number 1, we're asked, is parallelogram ABCD a rectangle, a rhombus, or a square? So we've got a key piece of information just in the question itself. It gives us the parallelogram symbol. So it's telling us it's not just a quadrilateral. It has the characteristics of a parallelogram. So it's got to be one of these 3 things. So if we go over and we identify ABCD, that's going to be this outside shape. So we want to keep our focus on that, not on the inside shape, which is EFGH. So with ABCD, we're told that we've got a right angle at angle B. Now, if we come back over to our list of characteristics for each of our quadrilaterals or each of our parallelograms, what we see is that rectangles and squares both have right angles at their corners. So this either has to be a rectangle or a square. In order for us to determine if it's a square, we need to know that all of the sides are the same length. It does not give us that information on here, so since it doesn't give us that information, we can't assume that all of these sides have the same length. So that means the most that we can assume about this is that it's a rectangle. In problem number 2, we're given that ABCD is a rhombus, and we're asked to find what are the angle measures of all of the numbered angles. So angle number 1 is here at the intersection of the diagonals. One of the rules that we know for rhombuses is that anytime that you have the intersection of diagonals, they're always going to be perpendicular bisectors. So that means that angle number 1 has to be 90 degrees. Then we come down here to angle number 2. Now, angle number 2, it sits along the same diagonal that bisects angle B. And we see that when angle B is bisected, it's split into 58 degrees and 58 degrees. So that means that angle 2 has to be 58 degrees, and angle 3 has to be 58 degrees as well. So if you have 58 degrees and 58 degrees, then that tells you that this entire angle right here is 116 degrees. That's going to help us to find angle number 4, because we know that with consecutive angles in a parallelogram or a rhombus or a square or rectangle, that they're going to add up to 180. So what we've got is 180 minus 116, and then that result is going to be divided by 2 in order to get angle number 4. So 180 minus 116 is going to be 64, divided by 2 is going to be 32 degrees. So we know that angle 4 is going to be 32 degrees because this other angle with it is also going to be 32 degrees. For problem number 3, we're told that parallelogram SBFR is a rectangle. And then we're asked to find what are the lengths of the diagonals of this rectangle. So going back to what we know about rectangles, we know that the diagonals are going to be congruent to each other. So since the diagonals are congruent to each other, and we're given the length of both SF and of RB, then all we have to do is take these two expressions and set them equal to each other, solve for x, and then plug it back in. So we've got 2x plus 15 is equal to 5x minus 12. Again, we're dealing with one variable here, and we've got a variable on each side of the equation. So we want to move the smaller one. So I'm going to move this 2x over, and that's going to give me 3x minus 12 is equal to 15. Isolate this x by moving the 12 over, so that's 27 is equal to 3x. Divide by 3, and so x is equal to 9. So now we know that x is equal to 9, we can plug that back into either one of our original expressions to determine what the length of the diagonals are. So to do that, plug 9 in for x. 2 times 9 is 18, plus 15 is 33. So we get 33 for SF. To make sure that we've got the correct solution, plug 9 in here as well. 5 times 9 is 45, minus 12 is 33. And so we see that we get the same measure for both diagonals. That means that we came up with the correct solution, x equals 9, and then both diagonals are both 33 units long.